This is Unit 4, Video 3, and this is Part B of our notes, where we will study equations and reactions. An equation is actually a way to represent a reaction that's taking place in the laboratory. So let's get to it. Let's quickly do a review of what a chemical reaction is. It's connected to a chemical change, and there's a change of a substance into a new substance that has different chemical properties and a different chemical identity. So if you've undergone a chemical reaction, you've changed one substance into a different substance. That's a reaction, and this is performed in the laboratory. An equation, then, is a way to represent that reaction. It's a symbolic representation of it. So here, for example, is a chemical equation representing a real reaction that we can perform in the laboratory. We can take this compound, called barium hydroxide, with this compound called hydrochloric acid, and produce this compound, barium chloride, and water. The compounds on the left are called reactants. The substances on the left are called reactants. On the right, they're called products, and what separates them is this arrow. The arrow separates the reactants from the products. So this is what we began with, and this is what we end up with. And that is represented here with this equation. Now, let's recall also the law of mass conservation. This is the first law of thermodynamics that we brought up when we talked first about chemical and physical changes. And this law says that the matter and energy of a system cannot be created or destroyed. What this means is that we have to have the same amount of matter, and matter is composed of atoms, before and after a reaction. So we cannot gain or lose any matter, which means we can't destroy or create any atoms. What this means for us is that our chemical equations must be balanced. So today's lesson will actually be about balancing chemical equations. So let's take a look at that same chemical equation we began with and ask this question: is this chemical equation balanced? The way to look at it is to count how many bariums you have on the left and on the right side, and do the same thing with the rest of the elements. So if we keep a little accounting, here we have barium on the left and barium on the right. So it looks like we have one barium on the left, here he is, and one barium on the right, here he is. So we have 1 and 1. Now, the number down here you'll see actually applies to the oxygen and the hydrogen, not to the barium. It only applies to whatever is in the parentheses. So in fact, this means that we have two sets of OHs, like this, which means you have 2 oxygens and 2 hydrogens. This is oxygen. That makes sense. So this number 2 actually does not apply to the barium. Alright, now if we count how many oxygens we have, then if I do oxygen on both sides, I'll see that I have 2 oxygens, because that 2 applies to the oxygen as well. I have 2 oxygens on the left, but if you take a look on the right, I have only 1 oxygen, which means this equation is not balanced. It's actually not balanced for the chlorines either. If you take a look, the chlorines, you have 1 on the left and 2 on the right. So this equation is not balanced, which means it's breaking the law of mass conservation, which means we have to balance it to make sure it does not break the law of mass conservation. These numbers in front, by the way, are called coefficients. We'll have to place coefficients to balance it. So we'll have to introduce this 2 in front, and we have to introduce the 2 in front right here as well. These are called coefficients. We'll use coefficients, and they simply tell us how many of those molecules we have. So for example, here we have 2 molecules of HCl. The numbers down below are called subscripts. Subscripts is what you write when you form a compound. When you write a formula of a compound, you put down subscripts. Hopefully this makes sense. Alright, so we're going to balance equations, and here are some tips for balancing. So first, balance the atoms that are in compounds. So if you follow these tips, you'll be able to solve the balancing problem quicker. But as you'll see, it's just a matter of practice. Second rule is keep polyatomic ions together. Now, a polyatomic ion, we may not have defined this. This is actually, poly means many, atom, so there are many atoms, and it's an ion. So here, if you take a look, this is magnesium, and this whole thing right here, SO4, is actually a polyatomic ion. The reason you know this is because magnesium has a +2 charge. So the whole group here of these atoms have to form a -2 charge to balance with magnesium's +2 charge. So this right here is a polyatomic ion. So if you keep them together, meaning if you just count, instead of counting the oxygen separately and the sulfur separately, if you simply say, well, I have an SO4, that'll make it easier. And then tip number 3 is balance single elements last. This is because you can put any number in front of the single element at the end you want, and so it's really easy to just finalize with that single element and balance it out. What we'll do is just practice a bunch, and then you'll get better and better at balancing equations. So let's balance these two equations. What I would probably recommend doing is kind of keeping track of the number of atoms you have. So we can keep track of the calcium, and I can keep track of the nitrogen on the left. I can also keep track of the calcium and the nitrogen on the right. Eventually you'll kind of do this in your head, but as you're doing it first few times, you can do it on paper. So ask yourself, how many calciums do I see on the left? Well, I see 1 calcium on the left, and I see 3 calciums on the right, which means I have to make sure I have the same amount on the left. You cannot add a 3 down here. This is actually illegal. You cannot do this because you'll be changing the formula of the compound. This is not allowed. What is allowed is to put a 3 in front, and this is called a coefficient. You'll actually add a coefficient in front. So I have 3 calciums on the left, I now have 3 on the right. Now, if you take a look, I've got 2 nitrogens on the right and 2 nitrogens on the left, so the nitrogens are balanced. So my calciums, I have 3 of each. My nitrogens, I have 2 of each. I have balanced the equation, and this was really simple. All you had to do was put a 3 in front of the calcium. Alright, let's do the second one. Let's do the same thing. You can keep track of the calcium, or the carbon, the hydrogen, and the oxygen here. Do the same thing on the right. Carbon, hydrogen, and oxygen. Alright, now I would begin with the carbon and the hydrogen and do oxygen last, because oxygen is by itself. Leave that for the end. Let's do the carbons first. So how many carbons on the left? Looks like I have 2 carbons on the left. How many on the right? Looks like I have 1. So I will have to double that up. I'll have to put a 2 in front, and that gives me my 2 carbons. That's what I need. Next, let's do the hydrogens. I have 2 hydrogens on the right. Notice that's 2 hydrogens. And I have 4 on the left. So let's change that. The way I'll change that is, again, I'll put in front a 2, and that multiplies by this 2 to give you a total of 4. And this is important. Whenever you put coefficients in front, that multiplies it to the rest of the compound. So in fact, here, as you'll see, you have now, on the right side, 4 oxygens. So since I have 4 oxygens there, I also have 2 oxygens here. Realize that this 2 means I have, this 2 applies to everything. So I have 2 plus 4, I actually have 6 oxygens on the right side. See if you can follow that. This 2 multiplies by this 2 to give me 4. This 2 multiplies by, technically there's an indivisible 1 here to give me 2, and I got 4 and 2, and that's how I got 6 oxygens. And to make sure I have 6 oxygens on the left, the question is, what do I put in front? Well, it'll multiply, which means I have to put a 3, and that's how 3 times 2 will give me 6. And now this equation is balanced. So you need a 3 in front of here, a 2 here, a 2 here, and technically you don't put anything in front, but technically there is a 1 there. You can put the 1 if you like, you don't have to, but this balances the second equation. Alright, let's do a few more, and then we'll set you loose to try some on your own. In this case it says, why don't we balance something that looks pretty complex. Now, to help us balance this one, we will keep the NO3 as a group. I'm not going to split the NO3 up. This is your polyatomic ion. So what I can do is I can count my calciums, and then I can count my NO3s. I'll just keep these separately. And I can count my NAs, and actually I can count my OHs. Here is another polyatomic ion. It's a little easier to see because oftentimes they are in parentheses. Alright, so I'll actually count my OHs as separate ones. Alright, those are the reactants. My products, I'll have the same thing. Calciums, my NO3s, my sodiums, and my OHs. And you'll see this will make the problem much easier. Alright, on the left side I have 1 calcium. On the right side I have 1 calcium. Those are balanced. Let's check how many NO3s I have on the left. I've got 2 NO3s because that 2 means I've got that many sets. 2 NO3s. On the right side I have only 1 NO3. So to balance this, I cannot put the subscript. I have to put a coefficient. That's the only thing you're allowed to do. I'll put a 2 in front, and that will give me 2 NO3s. Let's see how many sodiums I've got. I've got just 1 sodium on the left, and I've got 2 on the right. So I'll have to double up on the left, put a 2 in front, and that gets me 2 sodiums. And finally, the OHs, I've got this 2 that applies for both the O and the H. That means I have 2 OHs. And notice, on the right side, I've got 2 OHs. And the whole thing is balanced. So this was actually much easier than it could have been if you decided to remove and count all the separate oxygens. Now this will work. In fact, let's just take a look at the oxygens. If you take a look, there's 2 sets of 3. That's 6 oxygens here. There's also 2 more oxygens here. That's a total of 8 oxygens. So I have a total of 8 oxygens. Do I have 8 oxygens on the right? Well, I have 2 here. So that gives me 2 oxygens. And then I have 3 times 2. That gives me 6 oxygens here. Yes, I do. I have a total of 6 oxygens. So you could check separate elements, and you will find that that matches up if you use the rule. All right, let's try one more. This will be the toughest one, but I need to balance the carbons, the hydrogens, and the oxygens. Here is carbon, again hydrogen, and oxygen. All right, let's do oxygen last. Let's begin with the carbon. So it looks like I have 6 carbon on the left. I've got to have 6 on the right. All right, I've got 6 carbons on each side. Carbon's good. Let's do the hydrogens. I've got 14 on the left, and on the right I have only 2, so I've got to have 14. The question is, what goes in front to give me 14? Well, 2 times what is 14? That would be a 7. So 7 times 2, I've got 14 now. So my hydrogens are 14 each. Let's see how many oxygens I have on the right. Now, I have 6 times 2, that gets me 12 oxygens on this side. I also have 7 times 1, that gives me 7 here. So I have a total of 12 plus 7, I've got a total of 19 oxygens on the right. Now the question is, what do I put in front to give me 19? So 2 times what equals 19? Well, 2 times 9 gives you 18, 2 times 10 gives you 20, between 9 and 10 is 9.5. I can actually put 9.5 in here. Now, this was a decimal number. As you'll see, we'll have to remove this decimal number. But 9.5 times 2, in fact, does give me 19, and that balances it out. However, what I want to do is make sure that these numbers in front are whole numbers. I want the coefficients to be whole numbers. So the trick here is this. You'll multiply everything times 2. So if you multiply this whole thing times 2, you'll see that it will make it balance out. Let's go ahead and multiply everything times 2. So what I'll do is I'll put a 2 in front of here. 9.5 times 2 becomes 19. 9.5 times 2 is 19. 6 times 2 is 12. We'll put a 12 in front of here. And then 7 times 2 is 14. Put a 14 out here. And now if I calculate, I've got 2 times 6, that's 12 carbons. I have 12 carbons on the right side, that's correct. If I do 2 times 14, that's 28. I got 28 hydrogens. I've got 14 times 2, yep, that's 28 hydrogens. And then if I add 19 times 2 is actually 38. So let's see, I have 12 times 2, that's 24. And then I have 14 plus 14 is 38, and it matches up. So this one's a little tougher, but what you can do is you can use this little trick of using half numbers and then doubling them at the end. Alright, we'll actually practice a lot of this in class, and try a few of these on your own, balance these equations on your own, and we'll do the rest in class. This completes video 3.